Alright, what's up guys? So today we're doing the Nmap basic port scans. So this is the next step in the Nmap series of the junior pen testing path. This one, I wasn't really impressed with this one, to be honest with you. It was way more simplistic than I think is necessary, but that's alright. Alright, so here's some of the things we're going to cover. So you can see we're going to get live host discovery, basic port scans. So these are the four that are going to be covered in the entire Nmap series. We already did live host. That one wasn't bad. Basic port scans, here's what we're going to cover. But again, I'm not super impressed with it. I'll cover this stuff. All right. Hopefully everyone had a happy new year. This is day 2 of the new year, so we're good to go. All right. So here, TCP and UDP. My dog just cried. TCP and UDP ports. So again, I've covered this in the past, but TCP is connection oriented, UDP is connectionless. What that means we'll cover here, and you'll see an actual visualization of what I'm saying when I say connection oriented and connectionless. So here it says at the risk of oversimplification, which is true, but here is theoretically the two states that a port can be: open, something is listening, a service is listening, meaning something is running on that port using it, or closed, obviously nothing's using it. All right, so here it says, however, in practical situations we need to consider there's 6 stages that it could be in. There's 6 different options in Nmap. Okay, so you can have open, that means that port's open and typically susceptible to probing. Closed, pretty obvious, means nothing's running on it and that port is closed down, it's not going to be accessible. Filtered, now this typically is what you're going to see if you try to do this to your home computer or something like that. Usually if you just did a regular scan to your home computer, you're going to get filtered on most ports. This is Windows firewall blocking it. So same thing here, if any firewall is preventing you from reaching that port, okay, that's fine. Unfiltered means that Nmap can't determine if the port is open or closed. So that means the port is accessible, but they can't figure out what it is, okay? So open filtered, this means that the Nmap, again, can't tell if it's open or filtered. Closed filtered, same thing. They can't decide whether a port's closed or filtered. When it says filtered, keep in mind that means something's blocking you from going. So when it says it can't figure out if it's open or filtered, it's saying that it just can't tell if it's open because it's allowed to be, or if something is messing with that, okay? So that's what it means. All right, so which service uses UDP port 53 by default? And all they want you to do is just go here and say UDP port 53. That's all they're looking for. DNS, boom. They're literally looking for you to research it. And then the same thing with port 22. That's a TCP port. And okay, so they say FTP. And that's not right, so that means that research is bad, and I already know it's SSH, but so they just want you to do research. If you hit the hint, it says right there, requires external research. So super simple. They just wanted you to look that up. I have no idea. This is why I said I don't really care for this box, because that's not relevant to this box, right? We're looking at basic scans. We don't really care what port is running right now. That's something else. But okay, so how many ports does Nmap consider? So you can see here we have the 6. Okay, boom. Which port state is the most interesting to discover as a pen tester? This one they don't really give you any hint towards it, but it's pretty obvious, right? The one that you really are looking for as a pen tester is open. You want it to be open and ready to go, so that way you can try and enumerate information from it. All right, so this I'm not really sure why they threw this in here. It's good information to see, but it's not necessarily something you need to memorize, okay? So this is what a TCP header looks like. So what they're trying to show you is that this is kind of the format that it's going to be sent off to. So you're going to have your source port, your destination port, okay? Now TCP, it's connection oriented, so it's being sent in sequence. So let's say your first piece of information is number 1, second piece is 2, 3, 4, 5, 6, so on and so forth. So when you send this TCP packet, if 1, 2, and 4 gets there, it's not going to show whatever information is in 4 to the end user until 3 gets there. It's going to wait. And if it doesn't get it, it's going to send back, hey, I still need packet 3. I still need packet 3. I still need packet 3. So it needs to be in order, and therefore it's going to be used in a format that this is critical information. It needs to be sent, and it needs to all get here. Okay. UDP is not like that. UDP will take whatever you give it. Okay. And so that's why like your Netflix and video games and stuff like that, they can have packet loss, or they can have lag, for instance, or buffering and things like that. They can have that stuff and keep going. So like if you ever watched a YouTube video or a Netflix show or something that got blurry all of a sudden, that's just information being dropped, but it's not going to stop everything and go, hey, wait, we need it in full 1080. We have to wait for it to get to us. It's just going to keep going with it and say, oh, we lost a little bit of information, but keep going. They get the gist of it, right? That's the difference between UDP and TCP, typically. All right, so this you can look at if you want. It's just the breakdown of it, of a TCP header. It's not that interesting, but it's good information to know, okay? All right, so it says here, in particular, we need to focus on the flags that Nmap can set or unset, which is true. So I believe we've showed the TCP handshake before on this channel, but basically, and it'll show it here, I'll show you how a connection works with TCP, and then here's the flags that you can see from a TCP packet. So here you have urgent flag indicates the urgent pointer filed is significant. Cool. Again, points that the incoming data is urgent. ACK is just an acknowledgement. Push flag is asking TCP to pass the data to the application promptly. Okay. Reset is reset the connection. Okay. Get rid of it. So SYN is synchronize, used to initiate the handshake. FIN, the sender has no more data to send. That's it. The flags are pretty simple, right? What 3 letters represent the reset flag? RST. Simple. The main 3 ones we're going to be worried about today are ACK, SYN, and RST. Okay? Which flag needs to be set when you initiate a TCP connection? So it shows you there. It's the SYN flag, and that's how you're going to initiate that conversation. Okay? All right. So here's the different scans that we're looking at today. So TCP connect scan. So TCP connect scan works by completing the 3-way handshake. So this is what the 3-way handshake looks like. So every time you connect to a host or a server or anything and you are using TCP, you're going to do this 3-way handshake. So you're going to say, hey, boom, SYN flag, and that's saying, hey, I want some information from you. Okay? And then it's going to send back SYN ACK. So, okay, I want some information from you too, and I acknowledge that you sent that connection. So you're trying to synchronize with me. I'm trying to synchronize with you, and I acknowledge that you're trying to synchronize with me. And then we have to send back the acknowledgement again, and that completes it. Okay, hopefully that makes sense. I know it can get a little confusing, but it's very common in cyber in general that most people know SYN, ACK is the 3-way handshake. So we're interested in learning whether the TCP port is open, okay, not establishing a TCP connection. So this is important to understand that we don't want to actually keep this connection open, right? We're not trying to actually send information. We're just trying to probe if the port's open. So this is what the actual Nmap does. It sends the SYN, sends back the SYN ACK, then the ACK, so that connection's established. But then we don't want to send any information. We don't need to talk to you right now. So then we have to reset it. The reason we reset it is so that we know that connection's broke, and we just got our information, which was, can you connect to me? Yes. Okay, boom, let's close it out. So it says here again, and I've covered this in the last one, but this is important. If you're not root or sudo, so you're not a privileged user, a TCP scan, which is this, the TCP connect scan, is the only possible option. Okay? So the reason that's important is because if you run Nmap and you use a different flag set, and let's say you just try some different scan, right? And you're not a sudo or you're not root, it may actually just run and not tell you, but it's gonna always just do this. It's always just gonna do this. So even if you say, hey, run a UDP scan, this is all it's gonna do. So keep that in mind. You need to be root to run some of these scans, okay? All right, so these are Wireshark excerpts from these actual scans that they're running. And they're trying to show you that port 143 here, you can see it right here in the, there we go. Okay, so you can see it right here. Hopefully you guys can see that. But anyway, you can see that it actually sent back the SYN ACK, and then we set the ACK. So we actually have a real live connection. It's actually open. Cool. That's all they're trying to show you. They're just trying to show you the actual filter by, or packet by packet breakdown of it. Hopefully this didn't freeze on me. All right. So then we go, keep going down. And this is then they took the actual, just what's in it down. So they took out the information we need. And you can see port 143 is open. So this is the actual breakdown of it. You've got your SYN ACK, your ACK, and then the reset ACK. Boom. Pretty simple, right, guys? All right. So to illustrate the TCP connect scan, the following example returns detailed list of open ports. So this is them running the actual scan. So these are some of the options that you can run, right? So the attack F enables fast mode. So this decreases the number of ports from 1,000 to 100. So one thing to know, by default, Nmap only will scan the top 1,000 ports. Now, that does not mean 1 through 1,000. That means the most common 1,000 ports, okay? So it's important to know that. I don't know what's going on with this. All right, so it's important to know that, because if you think you're scanning 1 through 1,000, you're not. You're scanning a bunch of ports, okay? So keep that in mind. Now, it is worth mentioning that TAC R option can also be added to consecutive order instead of random order. So what that means is it's going to just scan these random order. It's not going to scan them 1, 2, 3. You can make that option here with TAC R if you want to. And it says here, this is useful when testing whether ports open in a consistent manner. So like when you do a reboot, do they come up in the proper form or do they come up randomly? That can show you some time delay, some troubleshooting, things like that. All right, so launch the VM and execute this. All right, let's do it. So it's telling us right here to actually just run this exact thing. And the nice thing is, I think in the later ones, they actually have you, they actually have it slow down. Yeah, so it's pretty fast. Okay, so it says here, a new service has been installed in this VM since our last scan. So here's the last one. What has been added? And it looks like POP3 has been added. Which port number was closed but now is open? And POP3 is 110. Whoops, I didn't type anything apparently. All right, and there's 110. And so I'll tell you another thing that's good to know. See how it says POP3 and it says here, what is Nmap's guess about the newly installed service? This is important because it's not, Nmap's not going and saying, hey, what are you running on this? It's taking that port number and what it's basically what its standard is, right? So 22 is SSH, right? Everyone knows that. But you don't have to run SSH on port 22. You can run whatever service you want on port 22. But Nmap's going to say port 22 is open, it's SSH because everyone knows SSH is port 22. That doesn't necessarily mean what's running there. So POP3 is a guess, okay? It's saying this is a very common port that almost everybody uses for POP3, so we're guessing it's POP3. So keep that in mind when you're doing these. All right, we're going to go ahead and start it right away. I got to terminate this one first, I guess. All right. All right, so that's the unprivileged users scan, the connect scan that we just saw. So this is a SYN scan. This is what's called a stealth scan. This is by default what it's going to use. It used to be a stealth scan. I would not say this is a stealth scan, okay? Just keep that in mind, guys. So this is what it does. TAC SS is the syntax. That's the options. Now here, this is what it looks like. It's going to send the SYN, synchronize, right? And then you're going to get response, synchronize and acknowledge. And before that connection ever sets, you're going to say reset it, reset the connection. Now the reason for this, because a lot of you are probably going, well, that doesn't make a lot of sense, right? Back in the day, the logging wasn't as good as it is today because we didn't have the amount of storage to sit there and store the logs over and over and over, right? So the logging wasn't very good. So what would happen is it would be told only log things that actually connect to us, right? Well, if that connection never happens, the log never happens, okay? So it was less likely to get caught in the logs. Nowadays, I'll tell you right now, you're going to get busted on this stealth scan. So keep that in mind. But it is a good scan to know. And it's important that you know it is by default what Nmap is going to use if you have root privileges. All right. And this shows you here, it's just another Wireshark, but it's going to show you right here what it looks like. So this is the ST, meaning the connection scan. And you can see you get the SYN, SYNAC, ACK, then the reset. Here, you never get that final acknowledge. You get synchronize, synchronizing, acknowledge, reset. So it just shows you the little differences in it. All right, so again, here it's telling you it's the default scanning mode. All right, and then here it ran the scan, and then it wants us to run it and see if we get different results. So we'll go ahead and run it. And it shouldn't take very long. And boom, so did we get different results? What's the new open port? All right, so we have SSH, SMTP, HTTP, POP3, RC. All right, so it looks like our IRC is the new one. So it's asking the new port. Boom. And what is the guess? Again, notice it says guess. It's not saying that's guaranteed what the actual service is. That's important to know. All right, so we got to terminate this. All right, so now we break over to UDP scans. So UDP, again, connection list. So here's a good example. So UDP packets, see how it's being sent, but there's nothing being responded? That's typical for UDP, okay? When you click on Netflix and you click on a show, right? It's sending you the show. You're not sending anything back. You're not saying, yep, I'm getting it, I'm getting it, I'm getting it, I'm getting it. You're just watching the show. You're just enjoying it. That's what your typical UDP orientation and conversation is like. Now, they might send you something back now and then, but it's not very common, right? That you're going to have this open connection all the time. All right, so here you can see UDP port is open. So what that means is if you send a UDP packet to their port and you get no response, that typically means it's open, which I know sounds counterintuitive, but if it's closed and you send it to it, you're going to get this ICMP destination unreachable, typically. So what that means is if you're not getting a packet response, that means it's accepting the information. It's not telling you no, it's accepting it. So that's where it'll actually gather that information. Now, keep in mind, this is not a guarantee. UDP is a little harder because it's not a guarantee, because they could just have some sort of rule set up to, if a UDP packet comes in, just drop it, meaning you're not going to get a response. And that's very common too. So keep in mind that these are all techniques that are very good, but you need to know how to scan multiple different ways because your results may not be perfect, okay? All right, so launch the attack box, use the terminal to execute. So SU is the UDP packet, and we're going to go ahead and go through this. So we got Nmap, attack SU, and then it wants us to do the faster, and then V just stands for more verbosity, however you want to say it, and then we'll go ahead and scan it. And you can see here, discovered open port 53, discovered open port 111, and it looks like it's actually requiring it to increase the send delay, whatever. Okay, so here we only had 68 and 111. Here we have 53. So let's see if that's the right one. All right, so 53 is the right one. What is the service? And it says here, well, we know that, all right, what is the service according to Nmap? So it's not actually giving us the service yet. We'll let it actually complete, but I don't want to have to sit here for that long and wait for it. So we'll see if it picks up. So this will happen, by the way, guys, if you're wondering. So you can see here, increasing send delay. So all that is it actually increases the delay that it's going to send. So instead of sending boom, boom, like port 1, 2, 3, 4, 5, it's going to be like port 1, port 2, port 3. And the reason for that is because, and it's going to be a little longer than that, and you can see here, it's because 11 out of 12 dropped probes since the last increase. So what that means is, sorry guys, what that means is the firewall or whatever rules they have set up is just dropping packets because it's noticing you're scanning is what typically happens. Okay, here we go. So we had to wait for it. So DHCP, domain service is the what they're saying it is, okay? So we had to wait for it to finish. But you can see, pretty simple, UDP. Now you notice it did take a little longer because packets were dropping. Cool, no problem. At least not on this. It would be a long process in a regular one, and we're going to cover that here. This is where I honestly think some of this could be summed up in 5 minutes, but they made it longer. And the fine tuning and scope is the only bread and butter in this that I really think is important. Now, I do think the connect scans and UDP scans and stuff and stealth scans are important, but I think going into this Nmap tutorials, you should probably already have a little familiarization, so you might already have known this, so it might be a waste of time. Okay, so when you're doing ports, we've covered this before. The syntax is you can do port like this, TAC-P 2280.443, and that's just a list, right? So it'll scan those three. You can do a range, so you can do TAC-P 1 through 1023 or 1023, or port 20 through 25. However you want to do it. You can request the scan of all ports by using TAC-P. So this is important. This is a common option that a lot of people use if they're using all ports. TAC-P, TAC. That's just going to scan all ports. Now, keep in mind there's 65,000 of them, okay? So that's important to know. Because if you do that, you're going to be there a while. It's not going to be a quick scan, okay? Now, this is really important. This is the bread and butter, I feel like. So you can control the scan timing with TAC-T 0 through 5, okay? 0 is the slowest, 5 is the fastest. Now, if you're doing an actual pen test or red team exercise, CTF, something like that. Now, CTFs are a little different because CTFs usually are coordinated and you don't have all day, right? So when that happens, you're going to speed it up, but you're expecting to get caught, right? Because it's a staged exercise. You're expecting to get caught. Now, when you're doing a pen test or you really don't want to get caught, you're going to be using 0 or 1. Now, it shows here, for instance, TAC-0 scans one port at a time and waits 5 minutes between sending another one. So let's say you're sending 65,000 ports you're scanning, right? Every 5 minutes it's going to scan one. Every 5 minutes it's going to do another. Every 5 minutes. You're going to be there for days, okay? Keep that in mind. That's important to know. Especially if you're on a time crunch by any means. Okay, so I will tell you, I've done some pen tests and I've done some red teams where we didn't just do the probes for Nmap, but when we create a reverse shell or we create a backdoor induced system or something, we have those actually only only send information back and forth once every 24 hours. So what that means is, let's say I'm on a Linux box and I want to list, right? So ls, that's the command I want to run. I could send that right now and it wouldn't send to that box for 24 hours. And then in 24 hours, I'll get the results. And then if I want to do something else, I'll do that. Now, I know that seems like a lot to you guys, or like really slow and methodical, right? And that's correct. It is very, very slow and methodical. But the risk of getting caught is so much smaller because what happens is they're going through thousands and thousands and thousands of logs looking for anomalies. Well, it's not one little anomaly. Cool. The log's probably not going to pop up. But if you notice a different IP address or a different MAC address all of a sudden sending a lot of information, it's going to raise some red flags. But if one packet comes every now and then, it's not going to raise a lot of red flags. And the reason for that is the same as if someone scans your network and you're in an enterprise environment, typically you're just going to get, something scan your network, block it. Cool, blocked, done. Now, that's how they notice, because it was a lot of information all of a sudden. That's not normal. Now, if someone just pings your network, they're not going to go block it. It's probably not even going to pop up as an alert. That's kind of the difference. Hopefully that makes a little bit of sense to you guys. All right, so it's asked us, what is the option to scan all TCP ports between 5,000 and 5,500? They just want you to get familiar with these right here, the port range, and being able to type that out. So it's TAC-P 5,000, 5,500, or through 5,500, easy. Now, next question, how can you ensure that Nmap will run at least 64 probes in parallel? So what that means is, in parallel means it's going to run them all at the same time, okay? So right here, they're showing you can run, this one's showing maintain at least 512 probes. That's what it looks like. Minimum parallelism equals 512. Again, what that means is they're going to run them all at the same time. So if you're scanning a bunch of hosts, it can run them at the same time. Now keep in mind that it's going to go slower if you have less computing power as well. So it's kind of a, you got to take some and give some. So again, that's just this command right here, but change that number to 64 and that's your answer. Now, what option would you add to make Nmap very slow and paranoid? Right here, T0, that's the slowest it can go, and that's in paranoid mode. Perfect. So in summary, we just learned a little bit about Nmap's very basics. We didn't even do very many scans. I don't know how much of this you guys knew already, how much of it is new information. Hopefully it is new information because that's kind of the goal here. But I feel like a lot of this is information you guys probably are already familiar with. So hopefully it's not. Hopefully you guys learned something new. And the bread and butter here to take away, I feel like, is this right here, the fine tuning and scope. I feel like if you take anything from it, take that away, because these scans you guys will do so often that you'll understand them without having to go through something like this again. And then it'll be, this is the information you want to avoid intrusion detection, to be paranoid, to be sneaky, to set the range of ports. That type of stuff is stuff you guys should know. So hopefully you guys liked it. I'm going to keep doing these videos. Hopefully you guys had a new year, and or a good year, excuse me. And hopefully 2022 will be better for you guys. And hopefully, if you guys enjoyed it, you hit that sub button, and let's hit 2022 right. Let's go, boys.